Hi girls, welcome back. So on Friday, you were working on getting a cube, okay, and hopefully at this stage you've it made and the trick of actually taping it together has helped you. So it's really good to put something kind of solid on the inside to help tape up the corners. The last side obviously would be the one side that will prove difficult, but yeah, we've looked at a net that's opening out a 3D shape out flat, and what we've done is assembled it into the 3D shape. As part of your classwork on Friday, besides doing the net, I asked you to get the surface area and volume of this cube. We measured on Friday that the edge length was 66.5 centimeters or 65 millimeters. It doesn't matter in which unit that you do it. Obviously, that will be a difference of the unit of 10 for each one. So, with that in mind, we are going to look at the surface area. And we know the surface area is length by the width will get you one surface. But you know at this stage that there's actually 6 that are all the same. You could do 2 front and back, 2 top and bottom, 2 sides. But at the end of the day, it's all the same calculation. It's length by the width and there's 6 of them. Okay, so we multiply our answer by 6. So it's going to be 6 times 6.5, because I'm working in centimeters, by 6.5. You're going to grab your calculator. You can type it into your calculator exactly as I have it, or you can go 6 by 6.5 by 6.5. It's all the one. 6 by 6.5 by 6.5 is 253.5 centimeters, and it's area squared. Okay, that's the surface area. Some people might have done this in millimeters, in which case it'd be 6 by 65 by 65, which is a massive number. It's 25,350 millimeters squared. Now you're probably wondering, I thought you said it was a unit of 10. Well, that's a unit of 10 and that's a unit of 10, and 10 by 10 is actually 100, and that's why that's 2 decimal places more. Okay, so that's where that is all coming from. So if you did it in centimeters, your answer there is 253.5 centimeters squared. If you did it in millimeters, that's 25,350 millimeters squared. Doesn't matter. The last thing I asked you to do with this, so that was very fast, was volume. And before we left, someone told me that the volume formula is length by the width by the height. And at this stage, knowing that the measurement is 6.5, it's going to be 6.5 by 6.5 by 6.5. So 6.5 by 6.5 by 6.5. Grab the calculator, type it in. That is 274.625 centimeters. It is a 3D, 3 different units. Cubed is where the cubed comes from. Now, I know some of you might have again used millimeters, and obviously this number is going to be massive. 65 by 65 by 65. 65 by 65 by 65 is 274,625 millimeters cubed. Again, that's a 10 by a 10 by a 10, which is 1,000, which is why the decimal has moved 3 places for this. That is what I was asking you to do on Friday. It was making the cube, and it was getting the surface area and the volume. Now let's look at the book. Okay, on page 213, that's where we left off. We looked at doing the net, okay? And I explained what a net was, and we looked at doing a net, and we made a net, okay? And we saw that there was 11 different ways of doing it, and a couple of examples are given there, but not all 11. It doesn't matter what way your net works, as long as when you cut it all up and add it all together, that you'll get the shape, the desired shape that you're looking for. I am going to look at example 1. The benefit of having a net is simple. You can just get the area of each of the surfaces and add them all up. Okay, and that's why a net is beneficial for someone who finds working with 3D shapes difficult. Well, if you do the net, you just get the area of all the surfaces, and it makes getting the overall area very straightforward. So I'm just going to explain where all of that comes from. So page 213. And what you've been given is a cuboid. Now, I've obviously sketched this very fast. It's not very accurate, but it's 5 centimeters tall. It's 6 centimeters wide, and it is 10 centimeters long. And I'm just going to sketch out how you get the net. Okay, so how that actually forms. So you have the front of it, you have the top of it, and then you have the sides of it. And obviously there's a side on both sides. And the front of it is carried on to the back, and that's the same side. So the front and that front is there. And then obviously the bottom of it and the top of it are the same also. So I have the top, the front and the side, and I've replicated that there's 2 of those, there's 2 fronts and there's 2 tops. It doesn't matter where you start, but I always like to think of the bottom of this as being the easiest shape to get, because when you open out the box, that is what's in the center of the whole page. So it is a rectangle, and we know it's going to be 10 long, and we know the width of it from the drawing is 6. So the length by the width, that's 10 by 6. Now, attached to the bottom of it, or the top of it, whatever you want to call it, is the front. And the front is a 10 by 5. So that was 6. I now need to add 5 onto it. So a measurement slightly smaller. It's a 10 by 5. And that's the front. And that was the top of it as such, which I call the bottom. So I've done the bottom bit, and I've done the whole front of this. And then you can see the top happens again. So it's the top, the front, and then the top again. So it's another 6. 10 by 6. And you can imagine all the way around this box, like there was here, there's 1, 2, 3, 4 sides all the way around the box. Okay, all the way around was 4. So I've accounted for 3. So I had a 6, a 5, a 6. So see the way it's every second one? So obviously I need to go another 5. 10 by 5. Okay, that's the size of that. And the last 2 sides that are missing, or the last 2 pieces that are missing, are the sides, which are here and here, the 2 sides. And that's a 6 by 5. And you can put them anywhere here or anywhere here. Because you have 6, you then obviously come up 5. If you have 5, you obviously come out 6. It doesn't matter which way you do it, just as long as you do it consistently. So this is 6, so I'm going to just put on the 5. So it'll be a 6 by 5. And this will also be a 6 by 5 for the other side. So I've accounted for all 6 sides. The 2 sides, the top, the front, the top, the front. And you can see it's every second one. Even side, top, side. That's every second one also. To get the total surface area, write it out for yourself. Top, side, top, side. Top side. Or top, front if you wanted to. Top, front. And then you can have the 2 sides if you liked. Top, front, side, side. The top was 10 by 6. 10 by 6 is 60. The front was 10 by 5, which is 50. The top was 10 by 6, which is 60. The front was 10 by 5, which is 50. The sides were 6 by 5, which is 30. And there's obviously a second one of those, 6 by 5, which is also 30. So to get the total surface area, you can just add up all of those numbers, and that is 280 centimeters squared, and you can do that all on your calculator. So the example that I am showing you is the example 1 on page 213. And it's just the surface area can be a really nice way the net can be a really nice way of getting the surface area of the solid. Okay, because you can visually see what all the sides are, you can measure them, you can get the actual calculation on it, and it is done. Today in class, we are going to do this now. You might not have to draw the net out absolutely perfectly like we did for this one and cut it out, but now you know how to do that. And you can see how beneficial it is to be able to measure and hold something in your hand. If you find it hard to visualize, to have something physical in front of you, it makes it easier to see. And that's why these nets can be very helpful. So on page 213 in your book, this is the net of a cube. The length of each side is 4. Now, on your reading of that, a cube means that all of the sides and edges are the same. The length and the width and the height is all 4. That means this is 4 and 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 4, all the way around. And there's 6 different squares, and you would know that from having this one done the other day. The only difference with the cube that we made the other day, which was a 65mm one or a 6.5 centimetre one, is that this one is 4 centimetres. That's the only difference. You're asked to get the volume of the cube and the surface area of the cube. So today in class, I'm going to outline a little bit of work. And you guys can start working on this now, but you're going to join me live first. But you can start working on these questions. Page 213. Today, I want you to do question 1, 2, 3, and 7. So that's on page 213 was 1, 2, and 3. And then plus page 214, you're going to do question 7. And that is what I would like to do today. Some people might finish early because you just get the hang of this. And question 9 is a nice one on page 215 if you are finished. Okay, so that's where we're going to leave it for today. So I've explained how to the correction of your homework from Friday. Today, I've explained an example which you should take down in your copy, which you should have taken down in your copy. And now you're going to start on questions 1, 2, 3 on page 213 and question 7 on page 214. But you're also going to join me live for attendance now. Thank you.